Hello people, so today we'll be solving LeetCode daily question, that is 2601 prime subtraction operation, and in this we are given a zero indexed integer array nums of length n, and we can perform the operation as many times as we want. We have to pick an index I that we haven't picked before and pick a prime p which is strictly less than nums I. Then we have to subtract p from nums I and we have to return true if we can make nums strictly increasing array using the above operation, or false otherwise. And a strictly increasing array is an array whose element is strictly greater than its preceding element. It's obvious. So we are having numbers as 2, 4, 9, 6, and 10. So the answer is true because based on this that we can pick the prime numbers which are smaller than 4 are 2 and 3. So if we'll just subtract 3 from this, so we'll be left with 1. And then we can go to 9, and we are having the prime numbers which are less than 9 are 2, 3, 5, and 7. So we can just subtract 7, or we can either subtract, I guess, if we'll subtract 5, yes, if we'll subtract 5 it will still work. We can choose either of them, and our nums will reduce to, in case we choose 5 over here, so it will be 1, 4, 6, 10, which is strictly increasing, or even if we choose 7, it will be 1, 2, 6, 10, which is strictly increasing again. Okay, so that's where the output comes out to true. Okay, so first what we'll have to do is we'll have to find the maximum element from the nums, so that is equal to find max function, find max in nums. And then what we'll be doing is, as we have to deal with prime numbers, so we'll be having a sieve array, so boolean sieve, so that will be coming from the function that is sieve of erasto I don't know spelling. Yeah, now let's have our current value to be 1 and our index to be 0. Now while index less than the length of the nums dot length, so firstly I'll be having to calculate the difference, so that will be equal to nums of I minus my current value, and then I'll be checking that if at n time difference is less than 0. Basically what we are doing is we'll be starting iterating from the very first uh, value which we can subtract, because if we'll subtract, obviously we'll have to subtract a smaller number from a greater number to make it strictly increasing, and then we can increase the number over here. So that's how we are going. So if anytime difference becomes less than 0, we cannot perform any operation, so we have to return a false. Okay, and then what I'll be checking is that if sieve of difference is true, or my difference is equal to 0 basically, then in that case I'll be incrementing my index and I'll be incrementing my current value. Else I'll just have to find the number till I can, so I'll be increasing my current value again, and at the end I'll just return true if I find the answer. Okay, now let's quickly write the function that is private int find max, and that is having int nums as an input, and we'll be having int max is equal to nums 0, and then we'll be iterating in the map. So for in nums, not in the map, sorry, in the array, in nums, so max is equal to maximum of num comma max, and at the end return max. Now next we are having the boolean array function, which is if boolean, and just to avoid any errors I'm just copying the name because obviously I don't know what exactly it is. It does not receive any arguments. Then it will be having the boolean array of c, which is equal to new int new boolean. Oh, we just need it of the maximum length, so max, and let's pass in here the int max variable, and it will be of size max plus 1. Okay, now let's do arrays dot fill sieve comma with true initially. Okay, basically we should generally just done the other way. We mark the all the indexes true, but let's say for now we are marking all the negative indexes, all the in the opposite way. Okay, so sieve of 1 is equal to true. Oh sorry, sieve of 1 should be equal to false. Yeah, now for int I equal to 2, I less than or equal to the square root of my max plus 1 I plus plus, and then I'll be checking that if sieve of I is true. If sieve of I, then I have to run another loop. So for int j equal to I into I, j less than or equal to max, and then j plus equal to I, I'll be marking all of those indexes as false. So sieve of j is equal to false. Okay, and at the end I'll just return the sieve, and now let's give it a run. Okay, nums of index minus current. Now let's give it a run again, and it gets accepted. Now let's submit it, and it works probably fine as well. Okay, so this was it for today. Thank you for watching.